Hello, wonderful students. Today we are starting chapter 2, which is about non-right trigonometry and volumes. We're starting with non-right trigonometry. So let's talk about what that word means. It means we're going to study triangles without a 90-degree angles. Okay, so good idea to put that on your notes. And then we'll get to volumes later in the chapter. All right, our first task is to complete investigation 1. A surveyor. So a surveyor is a person that measures land so that people know where their property boundaries are. A surveyor measures a plot of land in the form of triangle ABC, as shown in this diagram. Now, let's talk about this triangle for a moment. By convention, mathematicians around the world have agreed that we are going to name angles with capital letters, okay? And we're going to name side lengths of that triangle by lowercase letters. Also, by convention, we are going to name the side that is across from an angle with the same letter. So this is why this is angle A, and across from it is side A. We have angle B, across from it is side B. Angle C, across from it is side C. Okay, so by convention, we will normally do that. All right, we need to place these measurements on our diagram. So she measures A as 5 meters, B as 7 meters, C as 8 meters, angle A as 38.2 degrees, angle B as 60 degrees, angle C as 81.8 degrees, and this is given to 1 decimal place. Each of those angles are given to 1 decimal place. Okay, so we've completed number 1. Now we need to look at number 2. So number 2 says, calculate these ratios. This is just A divided by sine of angle A. Now remember, little a is the side that's across from angle A. So we're comparing the sine of that angle with the length of the side across from that angle. We're going to show our work here. So first of all, we'll do A over sine A. A was 5 meters, sine the angle A is 38.2 degrees. Okay, so we get our calculator out and we make sure, since we're using angles in degrees, that we are in degree mode. You can see there on my calculator, DEG means I'm in degree mode. If your calculator says RAD or GRAD, then you need to go to your DRG button and change it to degree. Okay, all right, so we're dealing with angles here. We're going to take 5 divided by sine of 38.2, and however you need to do that on your calculator, and we get 8.0853. I'll keep a few decimal places, but it says we want to 1 decimal place, so then I will round to 1 decimal place. Means 1 place after the decimal. So 8.0, but this 8 means I'm going to change that to a 1. All right, next one. B over sine B. So B was this side, 7, over sine of 60 degrees. So look at your triangle. Make sure you can pick these values off of that triangle that we labeled. And then let's do that. 7 divided by sine 60 degrees, 8.0829, which to 1 decimal place, 1 place after the decimal, 8.0, but that next one is 8, so it pops that to a 1. Next one, C over sine C. So angle C is 81.8, side C is 8. And we do that. that? 8 divided by sine 81.8, or however you need to do that in your calculator. And again, we're going to round to 1 decimal place, again is 8.1. Okay, now, next part, triangle ABC we have here. We're just going to compare the 3 ratios. What do we notice? We're going to write them here. Okay, we have 8.1 here, 8.1, and they were all equal to 8.1. They're all the same to 1 decimal place, right? If we go back and look at our values, they're not actually the same to this many decimal places. They're not even the same to 2 decimal places, because this would round to 8.09, 8.08, 8.08. Okay, but let me tell you this. This will always be true that these are equal if we were able to measure these distances, the lengths, as well as the angles more precisely with more decimal numbers after them. These would work out to be exactly the same number. Okay, so they are the same to 1 decimal place. Okay, or you could say they are equal. All right, so basically what we're saying is this ratio is equal to this ratio, which is also equal to this ratio. And this is going to be a very important concept that we study in this unit. Okay, next page. We have number 3. Triangle ABC is shown in the diagram below. Draw the height CH from vertex C. Here's the vertex C, that means this angle, towards side AB. Here's AB. Now, when we do this, we want to make sure that we're coming down to create a 90-degree angle on this line. So I'm going to do my best at that. I think 90 degrees would be about like that. Okay, so we're creating 90-degree angle here and 90-degree angle here. So we've just created 2 right triangles with 90 degrees in them, out of this one triangle that is a non-right triangle. Okay, draw the height CH. So we're going to label this point capital H from vertex C towards AB, and we're going to call this side CH. Label it H. Okay, so we'll label it H. All right, number 4. The height CH divides triangle ABC. The height CH divides triangle ABC into 2 right triangles. We already talked about that. This one, ACH triangle, and BCH triangle. Note that angle A belongs to ACH and angle B belongs to BCH. Okay, they also belong to ABC still, but we're just talking about the right triangles now. Write an equation in terms of sine A. What that means is we want to, sine A needs to be on one side of the equation, and H using right triangle trig. Okay, so we're going to use this triangle because sine A, we're talking about this triangle, this right triangle. Let's draw it here. We've got ACH. All right, this side we already knew. We're not going to talk about the actual lengths of them though. We're just going to use the letters that are labeled here. So that's side B, this is side H of that right angled triangle right there. We're looking at angle A because sine of A, so this is our angle. So if we use right angled trigonometry, remember sine of theta is opposite over hypotenuse. Hypotenuse. Okay, now let's fill in angle A. The angle is actually called A. The opposite is H. And the hypotenuse is here across from the right angle. So that's B. Okay. Now, number 5. Write an equation in terms of sine B and H using right angled trig. So now we're looking at this triangle. I'm just going to redraw it here. Again, this is H. We've got HCB. Now, I just want to talk about one thing. back here, we talked about by convention, we label these triangles. The side is across from the angle of the same letter. That's not happening in this case right here with H, only because we added the H into the bigger triangle. That's the only reason that's not happening. Okay, so we're taking a part of this triangle out. All right, so sine B. If we use right-angled trig again, and we can because this triangle has a 90-degree angle in it. Again, this is sine theta equals opposite over hypotenuse. We're talking about angle B this time, so sine B equals opposite, which is H, over hypotenuse, which was A. Okay, so now we have sine A equals H over B, the height over B. We have here sine B as H over A, the height over A. Number 6, write each of the equations from part 4 and 5 in the form H equals. All right, so we'll start with sine A equals H over B. And we're also going to start with sine B equals H over A. Our instructions are rearrange this so we have H equals. Okay, so in order to do that here, we're going to multiply both sides of the equation by B. So we'll have H equals B multiplied by sine. Let me rewrite that so it's a little better. I'll just show you some steps too. All right, so we're going to multiply both sides by B. I will write that down. Okay, when we do that, these ones cancel because B over B equals 1. And we have here H equals B multiplied by sine A. Let's just rearrange that, put everything on each, put the H on this side and put this on the other side. When we change everything, we don't have to change the signs. So B sine A. So this means sine A multiplied by the length of B. We'll do the same thing over here. Here we're going to multiply both sides by A. So A multiply on this side, A multiply on this side. And these ones cancel because they equal 1, A divided by A. And A sine B, let's multiply, equals H. So H equals A sine B. All righty, here we go. Next page. So the next question, number 7, says, equate the right-hand side expressions from the two equations in part 6. All right, so over here we have H is equal to this. Over here we have H is equal to this. Well, if they're both equal to H, and H is exactly the same height for these two triangles that are now attached to each other, then those two things that are representing H or equal to H must be equal to each other. All right, so B sine A equals A sine B. There we have it. Number 8, write an equation equivalent to your equation in part 7, regrouping first sine A and sine B. Okay, so what we're doing here is rearranging. We're starting with this from above, and we want to get sine A by itself first, so we're going to divide by B on both sides, by side B. Okay, that cancels this, and we have sine A equals A sine B over B. Okay, now we're going to divide both sides by A, okay, because we want to get B on the top. So divide both sides by A means we're going to, dividing by A is the same as multiplying by 1 over A. So we could do this. And that A multiplied by 1 over A, that equals 1, so those cancel. This now becomes sine A over A equals sine B over B. Okay, excellent. We could also rearrange it. I'm going to start back here at the top again. We could also rearrange it like this. Instead of dividing by B on both sides, this time around I'm going to divide by sine B on both sides. Okay. Or I could choose to divide by both sides on sine A in this situation, because we don't really know what we're solving for. We're just rearranging. Okay. So here I'm going to have, let's divide by sine B, divide by sine B. That equals 1, so we can cross it out. And over here we have B sine A over sine B equals A. And now we're going to make the A move to the other side. In order to do that, we need to divide both sides by sine A, the sine A. So we're going to divide by sine A, which is the same as multiplying by 1 over sine A. And now sine A and sine A cancel. Over here we're left with B sine B equals A over sine A. All right, so notice sine A over A equals sine B over B, or B over sine B equals A over sine A. Okay, this is going to be the important formula that we're going to study. So, conceptual thinking. Do you think if you had drawn the height from B to AC instead, you would have come to the same conclusion about ratios C over sine C and A over sine A, between A and C? Why or why not? Okay, so let's go back to our original triangle, which looked like this. Straight across here. Okay, there's our original triangle. We had A, we had C, we had B. So they're saying, what if we had now drawn the height from B to AC instead? Okay, when we do that, we have to try to make 90-degree angles here. So that would be 90 degrees. This would be 90 degrees. Okay, we're going to call this now point H, and this is going to be our height. 90-degree angle here, 90-degree angle here. So in this situation, we're going to find sine C using right-angled trig. We're going to find sine A using right-angled trig, just like we did back here in number 4 and 5. So if we did that, we would end up with the same thing. This would lead to knowing that C over sine C would be equal to A over sine A, just like it's saying here. So yes, this answer is true. Because of the nature of using dividing this triangle into 2 right-angled triangles, and then we would be able to go through the same procedure we just went through to find this, or when we rearranged, we could have found this. But notice that the letters are together within each ratio or each fraction, okay? And what that means is it's the angle and the side across from it. The side across from this angle. Okay, so that's the first concept we are studying. Your last page just gives you a good note. This one. Okay, here's the sine rule. All 3 of these things are related to each other if the triangle is labeled properly by convention, like we talked about at the beginning. Or these ratios will also be equal. We're going to use these to solve problems of triangles that do not have 90 degrees. Bye-bye.